Hey guys, it's Chris at Highline Guitars. In today's video, I'm going to answer some questions that have been submitted by viewers on some of my YouTube videos, and they've also been emailed to me on my Highline Guitars website. And these are all questions about building guitars that I think you'll find interesting. The first question will deal with how I fix warped or bent or twisted wood. I'm also going to talk about shielding control cavities. Then I'm going to talk about how I deal with wood that is subject to international restrictions. And then I've got a recipe for making a single coil pickup so that it has scooped mids. And then finally, I'm going to answer a question about potting pickups. When do you have to pot your pickups? And is it necessary to do that? So let's start out with the first question, and that is, how do I deal with wood that's warped, bent, or twisted? The short answer is, I don't. I simply don't purchase wood that is warped, bent, or twisted. And that's one of the reasons why I like to shop at my local lumber suppliers, because I can look at the wood from every angle to see if it's got any issues with warping, bending, or twisting. I have found from past experience that regardless of what techniques you try to use to mitigate those issues, they never completely go away. And some of the techniques that are used involve, for example, with warped boards, you can attach a warped board to a board that you know is flat. Typically that might be a thick slab of MDF. And you would screw your warped board to it. And obviously, since it's warped, part of the wood is going to be lifting off of that surface. So you would shim it. Then you would run that board through a planer, gradually planing off the surface until you get it perfectly flat and level. Then you would remove that board from the MDF, and then you would flip it over so that the plane side is down, and then run it back through the planer and then plane the other side until it's flat relative to the surface that you planed initially. That way you can eliminate all the warp that's in the wood and you have a perfectly plain flat board. Will it stay that way? If wood has a tendency to warp, it's going to continue to warp over time. It just doesn't matter. But in the time that you're working on the wood, you can get it plain flat. However, one of the disadvantages of doing that is you need to make sure that that wood is thick enough to account for all the material you're going to plane off of it. So if you're making a neck or a body, that wood needs to be thick enough so that if you do plane it flat on both sides using the method I just explained, you still have enough material left to make the neck or the body that you're going to make with that board. Oftentimes what happens is you plane away that warp, and then what you end up with is a board that's just too thin to be of any use. So you need to consider that before you make that decision to do it. Another way of dealing with warped or bent or twisted wood is to subject it to heat. And typically this is done with steam heat, because with steam heat, the steam vapor carries that heat deeper into the wood where it can relax the fibers of the wood. And then what you would do is after heating it is you would clamp it down flat and then let it cool. And then hopefully that would help to eliminate some of that bow or warp or twist that's happening in the board. However, I can guarantee the minute your humidity levels change, the board is going to change its shape again. It's going to go back to the way it was. The only times I've found that to be effective is when I'm trying to get a fretboard flat. And I will do that if I've got a problem fretboard that's got some warping or bending or twisting, right before I'm going to glue it down to the blank for the neck. That just helps to get it flat. And then once it's glued down and the glue is cured, it's not going to warp or bend or twist again. It's going to be flat to the shape of the blank that the neck is going to be made from. But in the end, I just don't think that it's worth the effort to try to flatten wood that's warped, bent, or twisted. And sometimes I know that when you're going to build a guitar, especially if it's for somebody else, you may have situations where the customer has sent you the wood that they want you to use to build the guitar. And when you get it, you find that the wood is warped or bent or twisted, and you've got to somehow deal with it. And what I have often done in those occasions is I've told the customer, I'm sorry, I can't use this wood. It simply isn't sufficient for making a guitar. So, I can search for something comparable, but I can't use that particular board. Other times, though, folks are very insistent that you have to use the wood. Maybe it has some sort of sentimental value. Maybe it was a board that was cut from an old barn or something that used to be in their family's possession, or a church pew or something like that. Some kind of wood that has some sort of meaningful value to them, and they absolutely insist on you using it. In those cases, you're just going to have to find a way to make it work. And what I will often do, though, in those situations, because I have had that happen to me, is I will tell the customer, I will make this guitar, but I'm not going to offer a warranty on it. And I will cut you a deal on a better price, but there will be no warranty. You will have to purchase the guitar as is, because I can't guarantee it's going to hold its shape for any length of time. So that's kind of my thoughts on the subject of using warped, bent, or twisted wood. Now, the next question was, when you have a control cavity cover, or a control cavity itself and the cover, you may notice that the control cavity cover has shielding on the back of it, usually a foil, and it can be a copper foil or aluminum foil. But then when you look into the control cavity itself, you may notice that it has black paint. You have to assume that that black paint is shielding paint, but you don't know that for sure. So how do you check to determine if that black paint is actually shielding paint? Well, the way you do it is you need to have a multimeter that can check for continuity. Set the meter for continuity, then place the probe at one end of the control cavity touching the black paint, and then the other probe at the other end of the control cavity touching the black paint. If you get a continuity signal, it is shielding paint. If there is no signal, then it's not. So that's just a quick and simple way to determine if that black paint in your pickup cavities or your control cavities is actually shielding paint. If you don't get that continuity, then it's probably just ordinary black paint. And if you need your cavity shielded, then you'll have to probably either purchase some black shielding paint or maybe get some copper foil shielding, which in my opinion works better, and then shield the cavities with that tape. Okay, so then the next question that came up is dealing with wood that might be subject to international restrictions. And the reason this came up was I had posted a video a while back where I showed off a piece of fretboard wood that I'm going to use. And this is called Bolivian rosewood. And a viewer was concerned that because it's rosewood, it's going to be subject to international restrictions. Now, this actually happened to me once in the past. I had built a guitar using this same kind of wood as a fretboard, and the guitar was going to be shipped over to England. Well, the guitar was intercepted at US Customs, and they seized the guitar because they thought it was made with East Indian rosewood, which was a rosewood that is controlled by the CITES Treaty, and you cannot export guitars with that kind of wood. So I lost the guitar. Now, fortunately, US Customs refunded the money to the customer, and I got to keep the money that the customer paid initially. So the customer got his money back. I got the money for the guitar that was seized, but nobody knows whatever happened to the guitar after that. I wanted it returned to me, but they couldn't find it. So somebody at US Customs got a really nice guitar. At any rate, the problem was the wood that I actually used in that guitar was Bolivian rosewood, not East Indian rosewood. There's a difference. However, visually, it looks like East Indian rosewood. And I think U.S. Customs policy, and this may be the same with other customs offices around the world, if it looks like East Indian rosewood, then it is East Indian rosewood. And the only way that you can avoid that problem is to have paperwork that confirms that the wood is not a wood that's controlled or restricted by international treaties. And I didn't have that when I sold that guitar. Lesson learned. In fact, I don't sell guitars internationally anymore at all because of the nightmare experience involved in shipping guitars internationally. Hey guys, if you're enjoying this video, I would encourage you to click the thumbs up button down below. Do it right now. It's a great way to show my channel support, and it doesn't cost you anything. But if you'd like to take your support to the next level, you can visit my eGuitar Plans web store or my Highland Guitars merch store. There's links in the description below. And any purchase you make there is going to help support this channel so that I can keep making guitar building videos and sharing my knowledge and experience with you. You can also click the thanks button down below and leave a tip in the amount that you think is fair. But if you want to get the most out of my channel, I would encourage you to click the join button down below and consider becoming a member. As a member, you're going to have access to videos just like the one you're watching, but with a lot more information and detail, and best of all, no ads. Now let's get back to the video. But as far as this wood here, Bolivian rosewood is not restricted. There's no restrictions on it at all. And you may be wondering, well, why is East Indian rosewood restricted, but Bolivian rosewood isn't? Or why is Brazilian rosewood restricted, but Bolivian rosewood isn't? Well, it's because Bolivian rosewood is not a true rosewood. When you see terms like rosewood or, mahogany or ash or ebony or anything like that, those are just common names. They are not the species and the genus names. So when you look at what East Indian rosewood actually is, it's a Dalbergia wood. That's the species of wood. And Brazilian rosewood is of the same species. But Bolivian rosewood is not. It's a totally different species. And it's not subject to any kind of restrictions. But if you build a guitar with this type of wood and you're going to ship it internationally and you don't have the right paperwork to confirm that it's Bolivian rosewood and not Brazilian or East Indian rosewood, you could be in some trouble and that guitar could be seized. And I've heard of even musicians who are touring and their guitar is inspected and then seized because they think it has a restricted wood in its construction, when in fact it may not. So if you're going to use wood that maybe have that potential to be interpreted as a restricted wood, you need to get paperwork from the lumber supplier as to exactly what that species of wood is in order to protect yourself from having the guitar seized. And it's also something that you'd want to include that paperwork with it so that the future owner would also have that paperwork and could prove it if they're ever traveling with that instrument, and could be therefore subject to seizure if they didn't have the proper paperwork confirming what the species of wood, all the species of wood that was used in the guitar. So that's how I deal with potentially restricted wood. In fact, that's really how you need to deal with all wood when it comes to shipping your guitars, especially overseas. The next question is, what would be a good recipe for a single coil pickup that would have scooped mids? Now, first of all, we have to define what scooped mids are. And in my opinion, and how I am interpreting the question, a scooped mid is when the mid-range frequencies are slightly lower than the treble and the bass frequencies. So here you have your treble, and then here you have your bass, and in the middle, the mid-range is down a little bit low. So you have this scooped shape. That means when you hear the guitar played with that pickup, you're going to have pronounced treble, pronounced bass, but then the mid-range is sort of subdued. It's withdrawn. It's lower. It's not as pronounced. So how do you achieve that when making a pickup? Well, we know that as a rule of thumb, when you wind the coil, the more turns of wire you can put on the coil, the higher the output signal is. But you also have more pronounced bass and mid-range frequencies and then lower treble frequencies. Oftentimes you'll hear people refer to that as a dark sounding pickup. That happens when you put a lot of winds on the coil. So as an example, let's say on this coil, the maximum we can fit on here is 10,000 turns. If you pack that with 10,000 turns, it's going to sound a lot darker. It's going to have a more bass and mid-range than it will treble when compared to a same size pickup that has, let's say, 8,000 turns. That's going to have more treble with the lower number of turns. So the rule of thumb is the more number of turns, the darker or warmer sounding the pickup is. The fewer the number of turns, the brighter or the more balanced the pickup will sound. Now, this doesn't take into consideration the magnet that you're going to use, and that's going to have a big impact on shaping the tone. So if you want a pickup that's going to have scooped mid-range, what you want to probably do is you don't want to necessarily pack the bobbin with as many turns as possible, but you don't want to go with a low wind either. You want to go somewhere in between. So if the pickup bobbin can hold 10,000 turns maximum, and 8,000 is the low end, you would want to do something in the middle, about 9,000 turns. Now, when you're trying to wind as many turns as possible, ideally you want to use a thinner gauge wire so that you can pack as many turns as you can. You can even go more than 10,000 turns if you want to really pack it. For a pickup that's going to have lower winds and a lower output signal, you would go with a thicker wire. So we'd measure that in gauge, obviously, and the higher the number of the gauge, the thinner the wire. Typically when making pickups, we use 42, 43, or 44 gauge wire. 42 being the thickest, 44 being the thinnest. So what I would recommend is to select something in the middle, a 43 gauge wire, and then wind around 9,000 turns, or something in between what a high wind pickup and a low wind pickup would be. Something right in that middle area. Then what I would do is I would use a ceramic magnet in the pickup. So the slugs would be ceramic magnet. If you're making a humbucker, the bar would be a ceramic magnet. And what that's going to do is it's going to maintain that bass frequencies, but it's going to jack up the treble frequencies. And your mid frequencies are likely going to be a little bit lower than both the treble and the bass. And that's going to give you that slightly scooped shape as far as your frequency response of the pickup. And that's going to probably achieve more or closer to what you want. Now, of course, tone is subjective, and when I hear scooped mids, you may not hear scooped mids. It has nothing to do really with the quality of our ears and our eardrums and our hearing. It has to do with how our brain processes the sounds that we hear. And sometimes people can hear things a little bit differently, or some people can detect very subtle quality differences while other people can't. So yeah, you have to consider that and take that into consideration and be mindful of it as we talk about the sound and the tone of pickups. But I think that's a great way to achieve that scooped mids. 43 gauge wire, a middle output range, and then a ceramic magnet. That should give you that response. Okay, the next question is, how do you know when you need to pot your pickups? Well, the reason we pot the pickups is to reduce amp squeal. You know, we have all experienced that, where you plug your guitar in, you turn on your amp, you crank up the volume, crank up the gain, and all of a sudden, depending on how you stand facing the guitar or facing the amplifier, you might get that high-pitched squeal. That's feedback. And what typically is happening is the sound waves coming out of the speaker are hitting the guitar and causing the guitar to vibrate. When the guitar vibrates, the pickups are vibrating, and when the pickups are vibrating, the coil and the magnetic field are vibrating, and that produces a noisy signal, which is transferred out of the guitar via the cable back to the amplifier, and then that sound is coming back out of the speaker again, hitting the guitar. So you get this loop, and it's a feedback loop, and that's what causes the squeal. Now, it's way more technical than that, but I don't want to really get into the complex technical aspects of what generates feedback, but that kind of gives you an idea. And that'll kind of help you to understand that. And this is something you've probably experienced when you've had that squeal. You might notice that depending on how you turn the guitar, it can change, it can eliminate that squeal, or it changes the way it sounds. So you know that the way the guitar is oriented towards the amplifier will have an effect. And that's just because of how those sound waves are bouncing. They're coming out of the speaker and then bouncing off of the guitar. And by changing the orientation of the guitar, you can affect the way that feedback sounds, or you can get rid of it altogether. In fact, a lot of pro musicians know that when they're standing on stage and performing in front of an audience, if they get the feedback, if they turn a certain way, they can get rid of it. But that's not always convenient. In fact, I've known guitar players who will stand in the same position for an entire show. And that's just because they're trying to prevent feedback from infecting their performance. So, unfortunately, that's not something that we want to have to deal with every time we stand up in front of an audience to perform. We want to be able to move around freely. And one of the methods for dealing with that is to pot the pickups. And what that means is you submerge the pickup into molten wax, usually paraffin wax, and then let it soak in, and then you pull it out, let it cool, and that wax surrounds the coil, all the windings of the coil, so that they won't vibrate when the sound waves hit the guitar, and that keeps that feedback squeal from happening. And the whole concept and technique of potting pickups has been done pretty much ever since the electric guitar has been in existence. Some of the earliest Fender guitars had potted pickups. And this is a technique that was borrowed from the radio industry, where coils and transformers were potted in order to prevent feedback in radios that people would purchase and put in their homes. So that same technique was then applied to pickups as well. And, there's the old urban legend about how Eddie Van Halen invented the process of potting pickups. And, he may have thought he was inventing it because he had never heard of it before, and many people who saw him doing that may have never heard of it before. But in truth, potting pickups has been going on for a lot longer. It goes back all the way into the 1950s. But what you have to do before you pot the pickups is you have to decide, is that feedback that you're hearing actually coming from the pickups themselves? Because there can be other causes for feedback. And what you have to do is you have to play detective and kind of rule out the different possibilities. And I think one of the best ways to test is to, first of all, try a couple of different guitars played through the same amp. And if you play a couple of different guitars, but only one of them has that feedback squeal, then you know that's the guitar. But if the feedback squeal happens on any guitar that you plug into your amp, then it's liable to be the amplifier or anything that's between the guitar and the amp itself. For example, if you've got a pedal board with several pedals on it, you're going to have to play detective and figure out, is it one of the pedals that's causing the feedback? And that can be an issue. So you have to connect and disconnect and each individual pedal until you figure out which one might be causing the feedback. But most often, the reason you're having feedback is because of what I described in the beginning. You've got those sound waves hitting the guitar. So it's the pickups that are causing the problem. And if you can isolate it to the pickups, then you can proceed with potting those pickups to prevent that feedback from happening. But before you pot the pickups, even though you may have isolated it to the guitar, you want to make sure that nothing else could be contributing or causing that feedback. And the first thing you're going to want to check is all the wiring in your guitar. And specifically, you want to check the connections. It's especially important to check your ground connections, but I would inspect all the connections, make sure you have good solder joints and that nothing is failing. Because if you have a problem with ground, you can end up with some pretty nasty feedback going on. So check all the wiring connections, make sure everything is okay. Then you can proceed with potting the pickups, and hopefully that's going to solve the problem with the feedback. If not, then it may just be something inherent in the guitar that you may have difficulty determining what it is. You'll have to keep doing your detective work. You'll have to inspect the hardware that's mounting the pickups. You'll have to look for high frets, because believe it or not, high frets can cause feedback. So, it's just an ongoing process of trial and error and a process of elimination to try to determine what's causing it. But by all means, pot those pickups if you think those are causing that feedback, and that should help. Now, of course, potting the pickups will change the tone of the pickups. However, it may be something you notice, it may be something you don't notice. I can tell when I pot a pickup, I can tell the difference in the tone. Others can't. So just be aware that it may have that effect. If you pot the pickups, it could change the tone of the pickups ever so slightly. So I hope that this video has been useful and informative and that you get something out of it. If so, please click the thumbs up button down below. And of course, if you want to take your support to the next level, you can do all the things I mentioned before. You can visit eguitarappliance.com, highlineguitars.com. There's links in the description below. You can visit my Highline Guitars merch store displayed below the description. You can click the thanks button. You can click the join button and become a member of the channel. And in doing so, you'll be able to watch videos just like this one, but with more information and detail and no ads. At any rate, until the next episode, as always, take care, stay safe, and I hope you'll be back for more guitar building videos.